In this episode, we will take a closer look at a common kitchen ingredient, starch. Although we use it every day, we rarely stop to think about what it looks like under high magnification. Today, we'll observe starch granules under the microscope and examine how they react when stained with Lugol's solution. I'll also answer an unusual question. What do starch and tree rings have in common? Starch is a substance that plants use to store energy. Chemically, it is a polysaccharide, a compound made up of numerous glucose molecules linked together in long chains. These chains can have a straight structure, as in amylose, or a branched structure, as in amylopectin. In everyday life, we associate starch primarily with flour, but it is also present in many other foods, such as grains, vegetables, fruits, nuts, and even some desserts. Plants store starch because their growth conditions change throughout the year. At night and during winter, when photosynthesis is limited, energy reserves help them survive difficult periods. Trees and shrubs store starch in their roots, trunks, and branches to support rapid growth in spring and to fuel fruit development in summer. It's impossible to talk about starch without mentioning plastids, the organelles where starch is produced and stored. Plastids are double membrane structures found in the cytoplasm of plant cells. Their immature forms, called proplastids, can differentiate into various types, including leucoplasts, amyloplasts, chromoplasts, and chloroplasts. Plastids have the remarkable ability to transform into different forms under specific conditions. A great example of this process is seen in potatoes. In underground tubers, the cells contain leucoplasts that store starch. However, when exposed to light, these leucoplasts convert into chloroplasts and start producing chlorophyll, giving the tuber a greenish hue. Prolonged exposure to light can also trigger the synthesis of solanine, a toxic chemical compound. Plastids create starch granules in layers, depositing new layers on top of existing ones. This process begins with young leucoplasts surrounding the cell nucleus, gradually producing starch. As a result, starch granules develop a distinctive layered structure. Starch can be easily identified through its reaction with iodine. Depending on the amount of iodine absorbed, the granules change color, from light blue to purple and even nearly black. This transformation happens within seconds. First, a light blue hue appears, which gradually darkens. Over time, however, the color fades, which is important to keep in mind if you want to preserve the sample for longer. Under a microscope, at the lowest magnification, 4 times, we can see numerous starch granules of various sizes. At 10 times magnification, their diverse shapes become more apparent, though the layered structure remains indistinct. Only at 40 times magnification do the characteristic concentric layers of the starch granules become clearly visible. Interestingly, when viewed under such high magnification, the layered structure of starch granules resembles the growth rings found in wood. If you found today's topic interesting and want to see more content like this, subscribe to my channel so you don't miss future episodes.